Okay, now that we've had a quick look at quadratics in standard form and the different parts that go along with graphing them, let's go ahead and take a look at an example, and then we'll try one on our own. You can see here we have f of x equals 2x squared minus 8x plus 6. And so the very first thing that we have to verify is that it's written in standard form and that we can identify the a, b, and c parts. Now, just by looking at it, we can have a pretty good visual idea of what this should look like. We know that the a value or the leading coefficient is greater than 1 or greater than 0, excuse me. So that tells us that it opens up. But that 2 also, if you remember, lets us know that it's a little bit steeper than your standard quadratic. And so, you're probably going to be able to tell just, that it's probably going to be a little steeper. It's going to be looking, opening up like that. And so that'll give you a good sense of what the final answer should look like. Now, we need a starting place. And if you recall from linear functions, our starting place was always the y-intercept. We wanted to find where it crossed the y-axis and work off of that point. In quadratics, what our starting point is the vertex. And if you recall, the vertex lies on the axis of symmetry. And so if we can find our vertex, then we can work around that point, and we can also work around the axis of symmetry. And so if you recall, we have this formula, x equals negative b over 2a. And if you take your a, b parts and plug that in, you're going to see x is equal to 2. Now, keep in mind that this is the axis of symmetry, x equals to 2, so that is a line, a vertical line that we can plot, and the x-coordinate for the vertex is also equal to 2. Now, we just need to evaluate this function for 2 to find the y value for the vertex, and you can see we come up with 2, negative 2 as our vertex. So we simply need to start off by drawing our vertex and our axis of symmetry. And so if I look at this sample down here, I would start off by simply just drawing that axis of symmetry. And keep in mind, that's not part of the actual graph. It's just a visual aid to help us see the symmetry. And then I'm going to plot the vertex itself. Now, the one thing about graphing quadratics is, 2 or 3 points is sometimes not enough. What I'm going to recommend to you is that you should get the vertex and then 2 points on the right side of the vertex or axis of symmetry, and then the symmetrical points on the other side of the axis of symmetry. So it doesn't matter which side you elect to get the 2 points off of, but what I'm going to suggest to you is that you just simply do a little t-chart action and pick 2 points on either side, or 2 x values on either side that would be relatively easy to find the value for. And so in this case, I'm going to use 0 and 1. And if I evaluate 0 and 1, I simply get 6 and 0 as my points. And you can see here that I have 2 points on that side. Now, from here, you don't have to evaluate anymore. This is where you're going to use your knowledge of symmetry to help you with the additional points. So since this is just 1 unit away from the axis of symmetry, my symmetrical point will be 1 unit away on the other side. Same thing here. This one is 2 away on the axis of symmetry, so I'm going to go 2 on that side. And now I have just enough points to sketch my quadratic as best I can. So make sure that you label all your points, or give me a table. That is very important, especially whenever we're drawing quadratics and we're not able to be as precise as we are with lines. So make sure that you do that. So let's look at the next one. Hopefully you've taken the opportunity to do these 2 problems by yourself already. I'm going to go ahead and work through these quickly. Be sure to stop the video if you need to look back at something and you are unsure. So first things first, I'm going to identify the a, b, and c. So I know here a equals negative 1, b equals to 2, and c equals to negative 2. Now this is a good visual. The negative 1 lets me know that it's going to be upside down. And I want to identify my axis of symmetry to start. And so I'm going to say x equals negative b, so negative 2 over 2a, so that's 2 times, 2 times -1, which is going to give me -2 over -2 equaling to 1. So my axis of symmetry is x equals to, sorry about that, x equals to 1. And I can simply take some little visual aid. You can either do a little highlighter function on the computer, or you can do just like a little dotted line, vertical line, just to kind of give you some guidance. Now, the next thing I'm going to do is I'm going to find my vertex. I need the point for my y value, and if I just plug 1 in and each of the x values, f of 1 equals to -1, so that gives me a vertex of 1, -1, and so you can see here that I have a vertex. Now, remember, I had a negative, and so I know that this thing's going to go down for me. And so now what you need to do, and this is where you want to use your calculator effectively, just t-chart a couple points. And so here, I'm going to t-chart a 0 and a -1. You could choose the 2 and 3, but what I'm definitely going to recommend is you pick one side or the other. And so here we have 0 gives us -2, and this gives us -5. So 0 to -2 and -1, -5. And then I want to find the symmetrical points on the other side of the axis of symmetry. And then I just do the best job I can to sketch that. Okay, and so that's how you graph a quadratic in standard form. And then, of course, you always got your calculator to help check that. So let's take a look at the calculator function real quick. If we look at the calculator function, we have f of x, and so I just want to put -x squared plus 2x minus 2 and hit enter, and you can see very clearly that my graph is looks the same. So that's a very good way to use your calculator. Alright, and then for this last one, I'm just going to go ahead and quickly do this. You can check your work against mine after I finish doing this. Okay, you can see here all of the work that I've done for part B. Now let me point out a few things here for you. The 1/2, if you recall, kind of opens that thing up a little bit. It makes it a little bit flatter. If you recall from our translations and transformations in prior units. And it is also going to open it up a little bit more. So if we go ahead and work here, we can find the x value for the vertex and the axis of symmetry, and then we can find the vertex. Now the first thing about the vertex you'll notice is we got a fractional component here. You can write that as a decimal or as a fraction, whatever makes it easier for you to graph. And also, please just estimate the 1/2, the 1.5 as best you can, and work off of that. Now, notice that when I plotted 0 and -1 for my x value, I didn't get a real clear-cut picture. And so what I did is I added a third point or a third x value to plot just so that I would get a better view. Now, you're going to have to make these decisions on your own, but I can tell you that I'm going to be looking for as concise a picture as possible. So if it means plotting an extra point, you need to go ahead and do that. So this is our first two examples of graphing quadratics in standard form. The next set of examples are going to use these skills, but not necessarily to graph.